Hello friends, in this video we are going to discuss the detailed analysis of Hstr 2015 Math Science question paper. So this will be very helpful for the Hstr aspirants. This is the first question of physics. It states that in astronomical telescope the focal length of eye lens and the object lens are such that. So here they are asking the relationship between the focal length of eyepiece and the focal length of object lens. So the answer will be focal length of object should be greater than the focal length of eyepiece. So here there is certain relationship which will help you to understand the relationship between the focal lengths. The first one is the astronomical telescope, then we have compound microscope, then the third one is simple microscope. This is the relationship of magnifying power. Magnifying power of astronomical telescope, magnifying power of compound microscope, magnifying power of microscope, simple microscope. So here it is, you should remember this relationship. In astronomical telescope, the focal length of the object lens should be greater than the focal length of eye lens, and in the compound microscope the focal length of object lens should be lesser than the focal length of eye lens. And the third one, here you need to remember that smaller the focal length, greater is the magnifying power. Since it comes in the denominator, if the focal length is smaller, then the magnifying power will be greater. They are in inverse relationship with each other. Hope you understood what is the relationship between astronomical, compound and simple. So this is important. These relationships are important. So you need to note it down. So here we have the relationship of the ray diagram of astronomical, compound and simple microscope. So you can go through it once. Second question we have, which of the following property of light does not support the wave nature of light? So we know that light have dual nature. So one is the particle nature and the second one is the wave nature. So here the wave nature does not support the photoelectric effect. It does not satisfactorily explain about the photoelectric effect, since the photoelectric effect shows the particle nature. Here the photoelectric effect is shown by the photons, which is the packet of energy. So here there are certain examples you can see. We have here reflection, refraction, photoelectric effect. Reflection and refraction was given by Christian Huygens and it was proposed with the help of wave theory of light. Both reflection and refraction was explained with the help of wave theory of light. Then we have photoelectric effect. Photoelectric effect was proposed by Max Planck, okay, and it was explained with the help of quantum theory. Then we have interference. The wave nature was explained with the help of principle of superposition of waves. The diffraction was given by the wave nature. It shows the wave nature. Even the polarization will show the wave nature. Diffraction was proposed by Huygens principle and polarization was proposed with the help of transverse nature of electromagnetic waves. Hope you have understood what is reflection, refraction, polarization, then we have diffraction and photoelectric effect. So photoelectric effect is the one which shows the particle nature of light. The third question is, the electromagnetic radiation which is caused for greenhouse effect on earth is infrared rays. So this is the reason, this gas is the reason for the cause of greenhouse effect. Fourth question is, the person uses a spectacles of power plus 2D. D here represents the diopter, which is the unit of power. This can also be asked for 1 marks. What is the unit of power? That is diopter. Diopter and power, they are inversely related to each other. We can say power and focal length, they are inversely related. Okay. So if a person uses a spectacles of power plus 2D, then he is suffering from the eye defect. So you need to say with the help of seeing this power, the person is suffering from which type of defect. So here we have the answer to it. The person uses a lens of power plus 2D. That means the person uses a convex lens. Okay, which lens do he or she uses? He or she uses the convex lens, which is used to correct hypermetropia. Hypermetropia is also called as far-sightedness. That means the person can see the far-lying object but not the closely near objects. Okay, far-sightedness represents far sight. Okay, what it says, the person who will have the sight of far-lying objects. So that is hypermetropia. So here there are certain relationship. You need to remember that myopia, in order to correct the defect of myopia, concave lens is used, and hypermetropia, convex lens is used. Astigmatism, cylindrical lenses are used. See, this is the trick you can remember. If it is plus 2D, then it is hypermetropia. If it is minus 2D, then it is myopia. So if suppose the magnifying power is positive, then it is hypermetropia. If the magnifying power is negative, then it is myopia. Then we have the fifth question. A body of mass m kg is lifted by a man to height of 1 meter in 30 seconds. Another man lifts the same mass to the same height in 60 seconds. The work done by them in the ratio. Okay, so what they are asking, there are two men who is lifting certain mass which is having the same mass to a same height of h. So we have to find out the ratio between the work done by these two persons. So here, this is the solution. Both work the same amount of work because they lift the same mass to the same height. The ratio will be 1:1. So as I told that the work done, in order to do a work of lifting a mass to a certain amount of height, okay, this work done is stored in the form of potential energy. And what is the formula for potential energy? It is mgh. So m is the mass and g is the acceleration due to gravity and h is the height to which it is raised. So here we can see that it is independent of time. There is no time in the formula of potential energy. So therefore we can say that potential energy is independent of time. Therefore the work done is also independent of time. Also we can say also work done is not dependent on time. So therefore if they are giving you the 60 seconds, this is just to confuse you. Okay, in order to if you are like they want you to get confused with different types of formula which will have time in it. Okay, so therefore you should not be confused with this time. You should remember that the work done is force into displacement. Here there is no time content. Okay, hope you understood the fifth question. Then we have the sixth one. A body of mass 5 kg is dropped from the height of 10 meter above the ground. Then the loss in its potential energy when it reaches the ground is. Okay, so what is the question? The question is the body of 5 kg is dropped from the height. So here suppose there is one body which is dropped from the height of h. Okay, suppose this is the h and it is dropped from the height h. The mass is 5 kg. So they are asking you what is the loss in its potential energy. If they are asking you the loss in its potential energy, loss means you have to find the difference, okay, when it reaches the ground. So therefore at this point the work done is stored in the form of potential energy. So at this point there will be one potential energy. When it reaches the ground there will be change in the potential energy. So we can say from the given data, that is potential energy is change in the potential energy from height h1 to height h2. as you can see, it is raised to a height of 10 meter. So h is here 10 meter. And here when it reaches the ground, what will be the h? H will be equals to 0 since there is no height and the object is lying on the ground. So therefore there is no height. So we can say h2 will be equals to 0. If this is 0, this whole term will become 0. We will get 5 is the mass of the mass of the object, and g is acceleration due to gravity, that is 9.8 they have given you. If it is not mentioned, you can take it as 10 meter per second also. Then 9.8, then height is height is 10 meter. So therefore potential energy will be given by 490 joules. Hope you understood this. This is the relationship between the potential energy PE is equals to mgh. Then we have the 7th question, that is the energy gap between valence and conduction band in the silicon semiconductor is. So as we know that semiconductor has the intermediate property between the conductors and the insulators. So this can be better explained with the help of their energy gaps. So see here, we have valence band and at the top we have the conduction band. So in the valence band there lies the valence electron, and in the conduction band there lies the excited electrons. So here in case of metals or in case of conductors, what happens is the distance between the gap between valence band and the conduction band is overlapped. There is no gap between the valence and the conduction band. So it is very easy for the electron to jump from valence band to conduction band. So it is called conductors. In case of insulators, what happens? The gap between the valence band and the conduction band is very large, larger than 3 electron volt. So there is a large gap. So electrons feels very difficulty to jump from the valence band into conduction band. If it is provided with sufficient amount of energy, then only it can jump from valence band to the conduction band in very rare cases. Then we have the semiconductors. In case of semiconductors, what happens? You can see here there is no gap and here there is large gap. This is very small gap, that is intermediate between conductors and insulators, right? Insulators. So therefore we can say semiconductors have energy gap intermediate between conductors and insulators, and that is equals to less than 3 electron volt. So that is your answer, that the energy gap between valence and conduction band in silicon semiconductor is less than 3 electron volt. For your knowledge, you need to note that the silicon has the energy gap of 1.1 electron volt and germanium have the 0.7 electron volt. This is also very important. They can ask you in the objective that what is the energy gap for silicon and what will be the energy gap for the germanium. You need to remember it. See here you can see I, L, I. So this is something like parallel things. No, you can remember it like this. So here it is 1.1. Okay, like that 1, 1, 1. So it will be 1.1 for silicon. And for germanium, you have it. If you remember silicon, the other, there is no need to remember. You can just understand, recall that it is 0.7 electron volt. Hope you understood. Then next, we shall move to the 8th question, that is, which of the following is Einstein photoelectric equation? So we have h nu naught minus h nu is equals to half mv max square. That is your relationship for Einstein photoelectric equation. This is very interesting phenomena. In my upcoming videos, I'll be explaining the detailed concept of photoelectric effect. Here, as for now, in short, I can say, suppose the electron is in the valence band, okay, ground state. If a photon of energy h nu is incident on it, what it does, it moves to the conduction band, that is the excited state. If suppose the energy gained by the electron, okay, is sufficient to raise it to the excited state, the remaining energy, that is half mv square, will help it to move out of the excited state. Okay, this is a very detailed and interesting concept. I shall discuss it in my next upcoming videos. Okay, for now you just remember that the relationship between the initial frequency, the final frequency, and the velocity with which the electron will move. This is the relationship. Then we have the ninth question, that is the truth table for the logic gate. So they have given you the truth table, that is A, B, A dot, B, and this is, see here, always you have to write it in the form of 0, 0, 0, 1, 1, 0, 1, 1. Okay, if you take the OR of it, okay, or you don't, for understanding you can just remember it, the OR can be the product. Okay, see, 0, 0 it will give you 0, 0, 1 will give you 0, 1, 0 will give you 0, 1 ones are 1. Okay, for your understanding, but it is not the product. Okay, then this is your OR gate. Okay, this is your OR. So in the question they have given like A dot B. This was the answer, 1, 1, 1, 0. So you can see this is opposite of OR. In place of 0 we have 1, 0, 1, 0, 1, 1, 0. So this was opposite. So therefore we can say bar of A dot B. Bar of A dot B is nothing but NOR. You can remember opposite of OR is NOR. Okay. Then let us move to the 10th question. Device used to convert alternating current into direct current is. Okay, device used to convert alternating current into direct current is the diode. This is very important and interesting concept of semiconductors. So this is diode. This is the diagram for diode. Okay, so it is denoted like this, it is drawn like this. This side will be the P side and this side will be the N side. That is P side of the semiconductor, N side of the semiconductor. We can say it is PN junction diode. So see, you can see here there is junction, right? So therefore we can say it is PN junction diode. The 11th one is dopants for P-type semiconductor. So which are the dopants for P-type semiconductor? Let's see here. We have P-type semiconductor and N-type semiconductor. P-type semiconductor is doped with trivalent impurities and N-type semiconductor is doped with pentavalent impurities. How will you remember? You can remember it in terms of PT teacher. Okay, we say PT teachers, right? Physical teachers, physical education teachers. So PT, you remember it PT. P means trivalent, N means pentavalent. Okay, if you remember one, it will be vice versa, right? P, T, so N, P. Pentavalent, P-type semiconductor is doped with trivalent and N-type semiconductor is doped with pentavalent. So which are the impurities? These are the dopants. Okay, the impurities added to the semiconductors in order to increase its conductivity, that is called as dopants. So which are the dopants of P-type, that is trivalent impurities, are boron, aluminium, gallium and indium. And for pentavalent it is arsenic, and antimony and phosphorus. You can remember it as Bagi. Okay, there is one film called Bagi, right? So we can remember it as Bagi. And this is app. Okay, app, we use WhatsApp. Okay, you can remember it as app. So it is arsenic, antimony and phosphorus. If you remember this, one question is for sure from the P-type and N-type semiconductor. Okay, you need to remember this. In many, like most of the time what happens is during the exam, the question is very simple. They will ask you the, suppose they will ask you gallium. They will ask like gallium is the impurity added to. Okay, you will be confused at that time. You remember that you have studied it, but at that time it is very difficult to recall it. So because of that, you have to develop a memory palace in your mind. Okay, so this will help you, that P, T and NP, Bagi for P-type and app for N-type. Hope you understood what are the dopants. Next we have a simple pendulum is moving in a periodic motion with periods T. Okay, it is, if its length is increased by 4 times, then its period will be. So as we know, we have one simple pendulum. Okay, see here. Suppose if you have a pendulum, sorry, this is your pendulum. Now this pendulum is under periodic motion, that is simple harmonic motion. This is the length of the string, okay, pendulum, and since it is lying against the gravity, there will be acceleration due to gravity g. As we know, the relationship between time period and the L and G, that is time period, is proportional to length of the simple pendulum and acceleration due to gravity g. If you square on both the side, what you will get, t square is proportional to L by g. Now since they have said the length is increased by 4 times, then the L is equals to 4L. If you substitute here, t is proportional to, in place of L, if you substitute 4L divided by g, so what will you get? Since it is root 4 will be equal to 2, right? So you can get this proportionality sign is given by 2 pi, okay, that is equals to 2 pi square root of this square root of 4, we can write it as 2 and L by G. So this is what, this is your time period and this is 2. So 2 into T. So therefore we can say it doubles, right? If the length is increased by 4 times, the time period will double, okay? It becomes 2 times of the initial time period. Then we have the 13th one, that is, if a simple harmonic motion, in a simple harmonic motion, acceleration of a particle is. So in case of simple harmonic motion, they are asking you the relationship between the acceleration. With the help of the relationship between the acceleration, you can solve this question. See, displacement from the mean position, okay, acceleration is given by minus a omega square. This is the relationship of simple harmonic motion, okay. When it attains the extreme position, suppose this is your pendulum, if it attains its extreme position, then its acceleration will be maximum, okay. And see, this is your potential energy. When it reaches to certain height, the potential energy is maximum. At the mean position, the kinetic energy is maximum, okay. As it comes down, the potential energy goes on decreasing and kinetic energy increases. So therefore we can say acceleration is equals to minus a omega square. And here we have velocity. For your understanding, just remember it. Velocity is given by plus or minus omega square root of a square minus x square. So see here, why this plus or minus sign is given here? This is to understand that it passes. Suppose a pendulum is moving from here to here. Obviously it have to come back, right? It will come back to its mean position. So it will pass through this point 2 times. While going up and while coming down, it passes through this point twice. So therefore it passes through the same point once in the positive direction of velocity. This is your velocity, right? The direction of velocity is here. In the positive direction of velocity, and in the negative, if it comes down, this will be the negative direction, opposite direction to the velocity. So therefore, since it is passing through the point, same point, once in the direction of V and another in the opposite direction of V. So this relationship is very important. In next Hstr, they can ask you the relationship between velocity. Okay, this time they have asked you acceleration. In the next, they can ask you about velocity, and even you have for displacement. Then let us see the 14th one, that is, when an electron jumps to the second orbit, that is n1 equals to 2, from any higher orbit, that is n2 is equals to 3, 4, 5, then the obtained spectral series is the Balmer series. So see, if suppose these are the energy levels, this is your 1, this is 2, this is 3, this is 4, and this is 5. Suppose the electron jumps from the level 1, level 2 to 1, level 3 to 1, level 4 to 1, and so on. This series is called as Lyman series. If the electron jumps from 3 to 2, 4 to 2, 5 to 2, this is called as Balmer series. Similarly, from 4 to 3, 5 to 3 and 6 to 3 so on, this is your Lyman-Balmer-Paschen. And then we have bracket, and last one is the P-Fund series. So this can be more understanding with the help of this diagram. You can see this diagram. Further numericals we shall be solving in my next upcoming videos. If you like the video, please hit the like button and subscribe to my channel and share with your friends. Thank you.